Hello, class. Welcome to Math 1220. This is Doug Schwartz, and let's talk about inverse functions. In fact, the written assignment is going to be a problem very similar to this one. So let's say we're given this rational function, f of x equals 3x minus 5 over x plus 6, and what we want to do is find f inverse, or the inverse function of that. That little minus 1 there, that doesn't mean f to the negative 1 power. That just means f inverse. That's just a notation for f inverse, the inverse function. And inverse is basically undo the original function. Like for instance, in real life, what's the inverse of drive? Reverse. So that comes up a lot in life. Okay, so let's find the inverse of this function here. And all we got to do is 3 steps. Step 1 is easy. Change f of x to y. So notice that's the same as that. Okay, and then, so that was step 1. Step 2 is going to be interchange all x's and y's with each other. So make that y an x, and then make all these x's y's. So that's a pretty straightforward step there. Wherever you see a y, make it an x. Wherever you see an x, make it a y. Okay, so that's done. And then step 3, the hardest step, solve for y. So how are we going to solve this for y? Let's make this look more like a proportion. So that's why I wrote x over 1 equals that. Set the cross products equal to each other. Doesn't matter which way you go first. I went this way first. What's x times the quantity y plus 6? And then set that equal to the other cross product. What's 3y minus 5 times 1? Just 3y minus 5. And now let's use the distributive property to get rid of the parentheses. So we have this now. And now comes the key step, because it looks hard. You got a y there, you got a y there. How are you going to solve that for y? Whenever you have y's like that on both sides, bring them together. So bring the y terms together, and we'll see why in a minute. So that's why I subtracted 3y from both sides, and I subtracted 6x from both sides. And that gives me this equivalent equation. And now, notice since we brought the y terms together, we can factor out that common factor of y. So now we can factor out the y. That's why we brought the y terms together. So take out the greatest common factor of these two terms, which is y, and what are you left with? X minus 3 equals that. And then divide both sides by that quantity x minus 3. And there we have it. We solve for y. And, you know, this is the same thing as that. Because these negative signs look kind of weird. You can leave it like that, though. But if you want to multiply top and bottom by negative 1, you get that. Kind of like use a distributive property for the numerator. What's negative 1 times that numerator? 5 plus 6x. And then this is going to be what? Negative x plus 3? Isn't that the same thing as negative x plus 3? 3 minus x. Each term has the same sign. So that's kind of a cool little trick. If you reverse the order, it's like multiplying it by negative 1 when you're dealing with the subtraction. Okay. And then if I wanted to, I could make that numerator looks better maybe if I write it in standard form. So isn't 5 plus 6x the same thing as 6x plus 5 because addition is commutative? So we have that. That looks a little bit better as the final answer than the original answer I got. But they're both the same. Okay, and once you solve for y, it's important to realize that's really f inverse. So I could have written f inverse equals this. So there it is. This is the inverse function of the original function right there. And so a function and its inverse, they have some really weird properties. It's very spooky. You know, I've talked about inverse functions before in algebra class. This is the first time I'm talking about it on Halloween, because I've even said in past semesters, this should really be done on Halloween. It's so spooky and creepy what goes on, the relationship between a function and its inverse, because of this idea. It's the x's and y's flip when you have a function and its inverse. So what does that mean? Let's look at the original function right here. What's the domain for this function? Isn't it going to be x can't be negative 6? So that's the domain of f. X cannot equal negative 6. And let's figure, okay, so what does that mean? If that's the domain of f, that tells us what the range is going to be of f inverse. The range is going to be y cannot equal 6, or negative 6 rather. Y cannot equal negative 6 is the range of f inverse. Let me see if I have that written down. Um, um, yeah, right here. What would be the range of f inverse? The range of f inverse is the same as the domain of f, except you just switch the variable, because range is always the variable y. So it's the same as the domain of f, where y cannot equal negative 6. Or in interval notation, it's going to be that. So that's cool. Because usually it's tough to find the range of a function. It's easier to find the domain. Let's look at f inverse. This is what we had for f inverse. What's the domain of f inverse? Isn't it going to be x cannot equal 3? Domain is x cannot equal 3, and this is for f inverse. So what do you think is going to be the range of f? The range of f should be y cannot equal 3. Okay, so that's very interesting. What else can I talk about here? How about, let's do a random thing here. For fun, find f of negative 5. So in your original function, if you got x equal negative 5, what's the output? So I get 3 times negative 5 minus 5 over negative 5 plus 6. So all I did was plug in negative 5 for all x's in f of x, which is right here. 3 times negative 5 minus 5, negative 5 plus 6. And what does that simplify to? Let me just find where I'm at here. So we want to find f of negative 5. I just made this problem up here. And notice you get negative 15 minus 5, which is negative 20 in the numerator. Negative 5 plus 6 is 1. And that equals negative 20. So don't we agree then, when you got x equal negative 5, the output's negative 20? So that is a point on the graph of f. What do you think is going to be a point on the graph of f inverse? The flip-flop. That's how inverse functions work. You know, you interchange x's and y's. It works with domain and range, because isn't that like x and y? And with ordered pairs. So guaranteed negative 20, negative 5 will be a point on f inverse. Then guaranteed negative 20, negative 5. Notice I just flip-flopped that ordered pair. Will be a point on the graph of f inverse. And let's just show that's really true. So what is f inverse of negative 20? Plug in negative 20 for all x's in f inverse, which is right there. So I get 6 times negative 20 plus 5, 3 minus a negative 20, and that gives me that when I simplify it, and that simplifies to negative 5. So indeed, negative 20, negative 5 is on f inverse. How cool is that? If I were to graph both f and f inverse on the same Cartesian plane, this is always going to be true for a function and its inverse. Like I said, it's very creepy. That's why it's cool we're doing this on Halloween. So the graphs of f and f inverse will always have symmetry about the y equals x line, which I drew as a dotted line here. So guaranteed, if we were to draw f and f inverse, and then you folded the graph about that y equals x line, the two graphs would coincide with each other. And then finally, even the asymptote switch. If we look at f, isn't the asymptote going to be x equals negative 6? So that's the vertical asymptote, x equals negative 6. That means the horizontal asymptote of f inverse will be y equals negative 6. Where's f inverse? Right here. And remember, how do you find the horizontal asymptote for a rational function? You look at the degree of the numerator and denominator. Degree of the numerator is 1. Degree of the denominator is 1. So divide leading coefficients. Or actually, make sure you, assuming it's written in standard form, which this denominator is not. So dividing coefficients of the leading terms, assuming it's written with the highest exponent first. So you get 6 over negative 1. Isn't that negative 6? And that's what we said it would be. What's the domain here for f inverse? X cannot equal 3. So what do you think is going to be the range for f? Y cannot equal 3. Sure enough, what's the horizontal asymptote going to be? Y equals 3. 3 divided by 1 is 3. Remember I said horizontal asymptote is super related to range? So y equals 3 is the horizontal asymptote. The range is going to be y cannot equal 3. All right, that was a cool little thingy. Cool stuff there. And I'll see you all next time.